Okay, and we're about to get this thing underway. So the technical walkthrough will be hosted by Roy Bisnet. Enjoy.
Thank you, Dan. All right, everybody. As I was saying, this is our 1 ton per day unit. We will not be running this in production mode. We're going to be running campaigns on it and doing some different products, going through and fine tuning our process. This is where we control the process, our human machine interface, where the PLC controls all of the variable frequency drives, pumps, motors, and so forth. So how this machine works is we bring the plastic feedstocks in. Heat hopper here. There's a double valve orientation there. It's an airlock that prevents oxygen from getting into the unit. As I mentioned before, pyrolysis, we require an anaerobic environment with no oxygen, so that when we take these solids that are plastics and we add heat to them and they turn into vapors, we can take those vapors and condense them into liquids, which I'll explain more in detail later. So the feedstock drops down through one valve, closes, then it allows it to drop down as needed to fill this retort. This retort, it's a tube with an auger inside, and it feeds through slowly. We adjust the speed of that retort with a variable frequency drive motor right here. And then once that goes through that first step of the process, that first pass, we'll drop down inside. You can't see it. And then we'll go into the second retort. The second retort is on a variable frequency drive as well, and we control the speed of that. That will obviously be a slower speed as we get everything else vaporized. As that makes its way through, that will then drop out. Any solids that remain are inert, carbonaceous. Will drop down in much the same way this one will with an airlock, and we'll collect it in a hopper. Very small amount. We're expecting maybe 2%, if that, depending on the feedstock, what we get. If we did post-consumer waste, we expect a lot more. But with the post-industrial that we're running, we don't expect that. So once we have the, I forgot to mention the heat. We have heat here. We have a burner down below here, a gas train. So when we start this process, we need heat to make the solids gasified. So we'll add heat through natural gas, propane, to get heat to the system to start that process. Once we start vaporizing products, we will have a non-condensable vapor stream that we cannot really use anywhere else, but we'll use it for the machine. So we are going to switch to that gas, pyrolysis gas, to fire the burner for heat to itself sustain. So where do the vapors go? Okay, the vapors come out of the vapor line here, and they will go over into this first condenser tool. And then we'll go through a wash. This isn't completely put together yet. We still have some other components put on here. But this is our particle wash system. This first condenser collection is our heavy oil, the material that will condense at higher temperatures. So our wax oil, if you will, heavy gas oil. As that vapor continues through, imagine there's another one of these here, comes through, we cool it down even further with more condensers with another particle wash. This is a lower temperature, and that's where we're going to get our lighter oils. So more of a light gas oil naphtha type product. So how are we controlling pressure on this thing? We run at a slightly negative pressure. That is done by using the compressor here. So we keep a slightly negative pressure on the system. And then we collect the gases here, which I mentioned before, we are reusing in the system. The condensing is happening with the cooling tower here. We have the cooling, our water goes through, cools, circulates for our condensing. And that's really about it. It's that simple. It can be complex. There are things that we can add to the machine. And we've got some really good ideas. And we're going to go through with some of those. But I can't wait to talk to you guys next time and show you this machine in operation. So over the next coming weeks, we'll be putting it together, and I hope to see you all ahead. Thanks for joining.